Hello, mentors. Let's talk a bit about the geometric center or centroid. And I know in another video we already covered what it meant to have or where could we locate the geometric median. And that was by trial and error. But in this video, we'll illustrate another possible center that will actually minimize not the distances, the sum of the distances, but the sum of the squared of the distances. So sum of square distances. So again, we have the map of California, and students already placed these 4 points, A, B, and the other AB for the other student. And they want to suggest some measure of center, right? Where to place these. So what they could suggest is, let's take averages in the horizontal axis and also then in the vertical axis and see what we do about them. So what they could think is, first, let's say using a ruler or a scale they can put and making approximations. Let's take the average between these 4 horizontal coordinates. Let's see, we have a 0, a 1, a 3, and a 4. So if we add these 4 values, 0, 1, 3, 4, we get 8. We have 4 points or 4 data points. So dividing by 4, 8 divided by 4 is 2. So we get x equals to 2. And that's indicated by this green line. Same for y. We're going to get 4. Let's see why. We have 1 plus 2 on the vertical. So that's 3 plus 6. And then plus 7. So that's 16 divided by 4. It's 4. And what we do then is we take the intersection of these two lines, or we just assemble the point of the averages we got. Visually, it looks reasonable. It looks like a good center in which all these 4 people would be willing to drive, right? I mean, B prime, it says, it's far. But then it says, okay, I'm kind of the worst case maybe with B, but it's not as bad. And in average, it looks good. So that's what it is. Interestingly, we could actually do these averages without any calculations and more with a geometric construction. We could, for example, forgetting about this point for now, just draw a line between any 2 points, for example, A and A prime. Take the midpoint, so that would be the average, a good center between these 2 points. Right? They would be both happy to drive there because they would drive exactly the same distance. Let's do the same for the other points, B and B prime. And let's take the middle. So the average, that's actually the average between these 2 coordinates. And then it helps that we have exactly 4 points, 2 here, 2 here. So the weights balance. And then we can take the average between these 2 points. So that will work. So we again draw a line, or students could draw a line between these 2 averages and then compute the midpoint, which can be easily done using a ruler or so. And then it actually matches the previous point. But so you could also do it with other choices of points. So you could maybe don't do it between A and B, but first between A and D. Let's just try and see what happens. So just changing here the parameters, let's say AD and AB, sorry, and AB. So these lower 2 points. So we did it with this, and then let's do it for the points that are up there. So don't worry about these parameters here, but let's just look at the picture. Okay, so that's good. So we have these 2 averages, and then we would draw a line, again, joining them and take the midpoint. So it's like magic, a lot of flexibility. It actually matches, again, this average, which in this case is 2.4, but it would be any place in California. It doesn't have to be a college, of course, or close to a college. Students could take a college that's kind of close, in which they would all be driving. So that's the centroid or geometric center. Again, it doesn't matter much about the names of these physics or math terms, geometric mean, geometric median, geometric center, centroid. So that shouldn't be too prominent. What's more important is about the visuals and about describing with actions and geometric language what you're doing and what's the concept. What are you minimizing? What you're making smaller so that it's fair for these 4 points to drive to this center. Okay, so have a great meeting.